Savikum. So we started with the reversible reaction in the last class, and today we'll be doing the application of the reversible reaction through the theory past papers. Now, before we start with the theory past paper, let's do a little recap of what we have done. Now, I said that the reaction which goes in both the direction are basically the reversible reaction. And when the reversible reaction take place, so the reactant they convert into the product, and the product in turn that converts into the reactant. Okay. Then the state will come where the both the sides they have the same speed of reaction. A and B combines to give you C and D. C and D in turn combines to give you A and B. So an equilibrium state acquires. That equilibrium state is known as dynamic equilibria. It is known as dynamic equilibrium. Now, this dynamic equilibrium is acquired when the speed of forward reaction is same as the speed of backward reaction, right? So it seems as if the reaction is not going in any one of the direction. It seems that there's no change taking place in any one particular direction. Neither the yield of product is increasing nor the yield of reactant is increasing. So whatever the amount of reactant you have, that remains constant, and whatever the product you have, that remains constant. So such a state, all the reversible reaction they acquire, that is known as dynamic equilibria. So we need to disturb the state, we need to disturb this state of dynamic equilibria in order to acquire either the reactants more or the product more. In order to make the reaction, we need to disturb the dynamic equilibria in order to attain either one side of the reaction, in order to attain one side of reaction. Okay, in order to make the reaction take place in one direction, either the forward direction or the backward direction. So we need to disturb this dynamic equilibria. We need to shatter this dynamic equilibria. Now we can shatter the dynamic equilibria by three factors, by disturbing the three factors. That means temperature is one factor. If we alter the temperature at which the dynamic equilibria was attained, so the effect of temperature, the effect of the change in temperature, the effect of the change in temperature can disturb my dynamic equilibria. How? Because if my reaction is, with every reaction, we need to know, it's most of the time it's mentioned whether it's an exothermic. If the forward is exothermic, then definitely the backward is basically endothermic. So if we change the temperature, if we increase the temperature, then it is always going to favor, it'll favor the endothermic side. So if I increase the temperature, which is an endothermic side in this scenario, if with the अगर आपके reaction के साथ delta H negative दिया हुआ है, तो that means the forward reaction is an exo, so automatically the backward is going to be endo. So if I'm going to increase the temperature, it's going to favor the endo. That means in the above scenario, it is going to the reaction, the equilibria will be shifted to backward direction. Okay, in this above scenario, the equilibria, because the backward is endo, so the equilibria will be shifted onto the left hand side, and I'll be getting more yield of A and B. Now moving, if opposite of that, if I decrease the temperature, then what happens? The decrease in temperature favors, it is going to favor the exothermic side. So in this scenario, that at the equilibrium, the dynamic equilibrium जिस temperature पे भी attain हुआ है, अगर उस temperature से मैं temperature lower down कर दूंगी, तो ये exothermic side को favor करेगा. इस scenario में the forward reaction is exothermic, so the equilibrium will be shifted. So the equilibrium will be shattered, and the direction of the reaction is going to go forward. So that's the change of temperature. Now we are going to, similarly, we are going to see the effect of the change of pressure. That's another factor which shatters the dynamic equilibria. But the pressure is only applicable in the case of gases. So if my gases are, let's take another example of the gases. If I have N2 plus H2, and it is going to produce 2 moles of NH3. gas. All of them are gases. So what do I do is, this is my balanced equation. I'll put 3 here. Now, when I have a balanced equation, what I'll do is I will add the volume of both the gases. So this is 1 volume, this is 3. So altogether, I have 4 volume here. And altogether, I have 2 volume here. So increase in pressure is going to favor the side with the reduced volume. Okay, with the reduced volume. So in this scenario, the reduced volume is the forward. So this decrease in pressure is going to favor the forward reaction. Whereas the reverse of
मिस
that,
आपकी आवाज लैग कर रही है.
okay, I'm sorry. I think इंटरनेट बीच में जो है वो गड़बड़ हो गया था. अब तो ठीक है. I know, I'm just recapping so that we can start with the past paper. So the decrease in pressure is going to favor, in this scenario, is going to favor the side with the increased volume, right? Increased volume. तो ये हो गया आपका factor A, ये हो गया आपका factor B. Coming to the factor C, that's concentration. The effect of change in concentration. Change in concentration. So in this scenario, अगर मैं A and B is going to give me C and D, अगर मैं A की concentration increase करती हूँ तो forward चला जाएगा. Similarly, अगर D की concentration change करती हूँ, increase करती हूँ, तो ये backward चला जाएगा. अगर A gas है, वो liberate out होती है, तो ये forward चला जाएगा, और डी अगर गैस है वो escape out करती है तो forward चले जाएगा, because one of the component goes missing, कि ये reverse नहीं हो सकता. Similarly, अगर A गैस है और वो escape out हो जाएगा तो फिर ये reverse चला जाएगा, because इस scenario में A missing out है तो ये forward नहीं जाएगा. So that is the effect of concentration. Now let's straight away after this, let's move on to the application of this through the theory papers. Okay, so here we start with the past paper questions. All right. Now it's here, it says that the first question, it's from June 2015. It's a question from June 2015. And the question states that, it states that the hydrogen react with halogen to form hydrogen halide. So this is hydrogen, it reacts with halogen to form hydrogen halide. And here they have given the delta H as a positive value. So that means the forward reaction is automatically is endo. The reverse reaction kya hoga? Wo exo. So this is basically they have given us. And apart from that, if it is H2 plus I2, the both are gases, is going to give me 2HI, which is also a gas. So if I add on the volume, अगर मुझे impact of pressure देखना पड़ेगा तो वो volume यहाँ पर भी 2 है और यहाँ पर भी 2 volume. तो that means effect of pressure कुछ नहीं होगा, because both the sides आपके volume of gases are same. Right now, this is the information I'm getting from here. Now let's read the question. What is the part of the question? The reaction is studied at the temperature of 400 degrees Celsius. Now, very importantly, they ask you to describe and explain what happens to the position of equilibria if the pressure is increased. As I told you, the effect of pressure is there will be no effect of pressure. Why? Because we have the same volume of gases on the both the side. It's 2 volume here. When you add it up, this is 1 volume of hydrogen combined with 1 volume of iodine, and you're getting 2 volume of hydrogen iodide. So when we add all the gases on the reactant side, I get 2 volume. When we add all the gases on the product side, I get 2 volume. So same volumes means that there is neither the effect, the impact will be of decrease in pressure, nor there will be impact of increased pressure. So describe and explain. So I'll write down no effect of change in pressure. Now I need to, this is what I have described. I need to explain now, because same volume of gases on both reactant and product side. Okay, so 1 mark for describing and 1 mark for explanation. Coming to the next question, it says that the reaction is studied at 25 atmospheric pressure. describe and explain what happens to the position of the equilibria. That means which side the equilibria will be shifted if the temperature is decreased. Now, we always know that the decrease in temperature uh, always favor the exothermic side. So that means the reaction is going to go in the backward direction. So first thing is I'll describe. So I'll say that the reaction on decreasing the temperature, the reaction will proceed in backward direction. In backward direction. Now I need to, this is for 1 mark, this is predicting or explaining, which is 1 mark. And the second mark is for the explanation, because decrease in temperature favors the exothermic the exothermic reaction, which is a backward reaction over here. Okay, coming to the next part of the question. The next question, in fact, this is again the question from June 15, and it states that ozone are continually being broken down and formed in the upper atmosphere. Ozone molecule decompose into oxygen molecule in a reversible reaction. So this is an equation. You're getting 2 moles of gas here, and you have a 3 mole of gas oxygen here. And the reaction, the forward reaction is basically, again, the forward reaction is endothermic. So the backward reaction is going to be exothermic. Okay. Now let's see what is the demand of the question. It says that the reaction is studied at the temperature of 400 degrees Celsius. Describe and explain what happened to the position of the equilibria if the pressure is increased. If the pressure is increased, then it is going to favor the side with the reduced volume. Now, if we check it out, we have got 2 volume on this side and we have 3 volume on this side. So if we increase the pressure, so the fact we will write down for the 1 mark. So we'll write down the increase in pressure favors the fact will write down the reduced volume. So the equilibria will be shifted to backward direction. Now, in this statement, I have written down the prediction in the later on, and I have given the explanation first. The explanation, when equilibrium pressure favors a reduced volume, and this is going to impact the equilibrium will be shifted to the backward. So I have reversed my answer. I can write it down this way as well. We have the next part. The reaction is studied at 25 atmospheric pressure. Describe and explain what happened to the position of the equilibria if the temperature is decreased. What type of reaction we have? We have forward as an endo and backward as an exo. So decrease in pressure, decrease in temperature always favor my exothermic side. Okay, so because of this is again an explanation. Because of this, the equilibria will be shifted, and now I'm doing the prediction, or this it will be shifted onto the backward side, will be shifted to the backward side. Okay, it will be shifted to the backward side. So we have done the 2 questions on the basis of prediction, how the equilibria is going to move forward or backward on the basis of increase and decrease of the pressure and the temperature. Let's see what do we have further. Okay, this question is again prediction and explain. It's from 2010 and it again says predict and explain. जैसे ऊपर आपको question पूछा था, describe and explain. So instead of using the word describe, they're using the word predict and explain how each of the following affect the position of the equilibria in this reaction. So this reaction is basically where we have carbon monoxide, which is a gas, combined with chlorine, giving you COCl2. And this is a balanced equation. So when these are both gases, and this is also a gas, so we are getting one volume and one volume. So on the reactant side, we have two volumes altogether. And on the product side, we are just getting one volume. So here, the first part is, okay, my internet connection is unstable. Am I audible now?
Yes, miss.
ओके अब यहाँ पर फोकस क्या है, वो कह रहा है कि कॉन्सेंट्रेशन को आपको इंक्रीज करना है, किसकी? क्लोरीन की। अगर मैं क्लोरीन की कॉन्सेंट्रेशन को, इफ आई एम गोइंग टू इंक्रीज, रिएक्टेंट की कॉन्सेंट्रेशन इंक्रीज करूंगी, तो इफेक्टिव कोलिजन्स जो होंगे वो रिएक्टेंट साइड पे होंगे, तो ऑटोमेटिकली आपका प्रोडक्ट बनेगा। ठीक है, तो प्रिडिक्ट क्या करेंगे? प्रिडिक्ट वी विल बी सेइंग दैट द रिएक्शन will be the forward reaction will be favored, right? When we will be increasing the concentration of chlorine, right? When we increase the concentration of chlorine, why? Because it is going to lead to frequent effective collisions, okay, of reactants, which is which is going to produce what? More of product, which is going to give more yield of product, right? Now the second part, they're asking about the increase in the pressure. We have the two volumes here and one volume of reactant product. So increase in pressure always favor the side with the reduce. So my prediction is that the reaction is going to go in the forward direction. Now, why in the forward? Because increase in pressure favors the reduced volume. ठीक है, तो ये हमारा सेकंड पार्ट हो गया। नाउ इंक्रीजिंग द टेम्परेचर, इंक्रीज इन टेम्परेचर ऑलवेज फेवर द एंडोथर्मिक साइड। तो प्रिडिक्शन क्या है, यहाँ पे इन्होंने डेल्टा एच नहीं दिया, लेकिन इन्होंने कहीं ना कहीं आपको इन्फॉर्मेशन जरूर दी होगी कि रिएक्शन किस तरह का है। Now, they're saying carbonyl chloride COCl2 is a colorless gas, poisonous gas formed from the carbon monoxide and chlorine combined in the presence of sunlight. The forward reaction is exothermic. Now, they in the statement form, they have said delta H, the forward is basically exothermic. So we denote it by minus sign, kilojoules per mole. And the increase in temperature always favor the endothermic. अगर forward exo है तो backward क्या होगा? Backward end होगा। तो हमारा prediction क्या हो गया? हमारा prediction हो गया कि reaction will go in the backward direction. Explanation क्या है? Increase in temperature favors the endothermic side. ठीक है, endothermic side. So one mark is for the prediction, another mark is for the explanation. Okay, so now they're asking you, a scientist investigated the thermal decomposition of calcium carbonate in a closed system, right? So in order to have an equilibrium scenario for the reaction to reverse, one of the condition is that you need to have the closed system so that none of the gases they escape, neither the reactant gases escape out nor the product. If all the reagents remain there for the forward to proceed in the forward direction as well as to proceed in the backward. Now, a dynamic equilibrium mixture is established. So, what do you mean by dynamic equilibrium? They're asking you the definition of dynamic equilibrium. So, dynamic equilibrium is basically is a state of reversible reaction. Okay, where the speed of forward reaction speed of forward reaction is same as speed of backward reaction. So it seems there is no net gain in any direction. That means आप observation में आपको लगेगा as if reaction हो ही नहीं रहा. There is no net gain neither in the forward direction not in the backward direction. Coming to the B part, the pressure of the equilibrium mixture is decreased. Now they're decreasing the pressure. Okay, they're decreasing the pressure over here. Okay, but the temperature they're keeping constant. The temperature of the closed system is kept constant. Predict and explain what will happen to the composition of the equilibrium mixture, what will happen to the reactant and to the product at the dynamic equilibria. What they're doing, they are decreasing the pressure. So if you decrease the pressure, you need to check the volume. Now we can see we have only the solids on the reactant side, and we have, this is also solid, and we have carbon dioxide as a one volume. So because we don't have the gases on either side, so there is no effect on pressure, because in order to have the effect of the pressure, we need to have the gases on both the side, and then after we have the gases on the both side, we need to check the total volume of the gases on the reactant side and the product. Now here the reactant side you have only solid, then on the product side you have one solid and one gas. Okay, that's okay that one of the component is gas, but on the reactant side we have no gas. So here there is no impact of the pressure change on the equilibrium mixture, because we don't have the gases on both the side. If the gases volume, if the volume of gases is same on both the side, same on both the side, then also no effect of pressure. Okay, one scenario. And similarly, if you have gases either as reactant or as a product, they are not present on both the side, then also no effect of pressure. Okay, so we'll write down the predict and explain. So they are asking about the composition of the equilibrium mixture. So predicting, no effect, no effect on the composition, on the composition of equilibrium mixture. Reason, because there are there are no gases on reactant side. Okay, so this is what they expect from us. The same question, C part. Now we have the gases only on the product side. Now it says that the temperature of the equilibrium mixture is increased. The temperature is of the equilibrium mixture is increased. The pressure within the closed system is kept constant. The position of the equilibrium shift to the right hand side. It's going on the right hand side. Now, what conclusion can be made about the enthalpy change? What conclusion about the enthalpy change of the reaction? They're asking what enthalpy change will be. Will it be an exothermic or it's going to be an endothermic? They are saying that, now this is the clue they have given us. The clue is that the temperature, when you increase the temperature, they're saying that the position of the equilibrium is going on the right hand side. It's going on towards the product side. So we know that the increase in temperature always favor the endothermic. So that means the forward reaction is going to be an endothermic, because it is helping the position of the equilibrium is shifted to the right hand side when you increase the temperature. So what is the conclusion about the enthalpy change? So we'll write down that the forward reaction is endo, because when you increase the temperature, when we increase the temperature, the equilibrium shifts towards the forward direction, because the increase in pressure or temperature always favors the endothermic side. Okay, good. Okay, we have the question that says that nitrogen dioxide NO2 react with itself to make the dinitrogen tetroxide. It's an exothermic reaction. So they have not mentioned anything with the equation, but the statement is saying that the forward reaction is basically exothermic. If the forward is exothermic, so automatically the backward is going to be your endothermic. So this is what the statement is telling us. So the forward reaction is exothermic. This reaction is investigated at 140 degrees Celsius in a sealed container. Sealed container means it's in the closed system that none of the gases are allowed to escape. The dynamic mixture is established between these two gases. You have the 2 moles of NO2 and you have 1 volume of N2O4. The NO2 is a dark brown color gas. It's a dark brown color gas, where N2O4 is a colorless gas. Further information they're giving you, this is a brown color gas, whereas this is your colorless gas. Okay. Now, what is meant by this arrow? This arrow shows that the reaction is reversible, right? Or you can write down that the reaction will go in the forward direction as well as in the backward direction. What is an exothermic reaction? So exothermic reactions are those which liberates heat energy during the reaction. We can write down which gives out or which liberates heat energy during the reaction, during the reaction. Okay. Now further, it suggests why the seal container is used to establish an equilibrium. We require a closed system, or the seal container, so that none of the gases escapes out. Okay, so they remain in the system so that the reaction can go in the forward direction or it can go in the backward direction. Moving ahead, we have the next question. The pressure of the equilibria of the mixture is decreased. So the pressure is basically, it has been decreased, and the temperature is kept 140. Predict and explain what will happen to the color of the equilibrium. Now, the focus is on the color, so you have to write it down accordingly. Let's go back and see what is they're decreasing the pressure. So the decrease in pressure always favor the side with the increased volume. So prediction is that the reaction will will go in because आपका decrease in pressure, increase volume, so increase volume is to volume, will go in the backward direction. ठीक है, और backward direction का color क्या है? The color of NO2 is basically brown. So reaction will go in the backward direction and the color of equilibrium will be brown. ठीक है, क्योंकि आपका NO2 ज्यादा से ज्यादा form होगी सही. So in terms of observation you have to write down. Now similarly the temperature, the next part is the temperature of the equilibrium is decreased. अब temperature आपने decrease कर दिया और हम ऊपर पढ़ कर आए हैं कि NO2 is going to give you N2O4, and the forward reaction was exothermic. As far as I remember, it is basically exothermic, right? So it's in now what are they doing? Their temperature has been increased. So what will happen to the color of look here, let's go back to the equation. The forward reaction is an exothermic. So when the temperature is increased, so the increased temperature is going to favor the endothermic side, which is again a backward reaction. So the color of the equilibria will go brown. So we'll predict that it will again going to go in the backward direction. The equilibria will be shifted to the backward direction because the backward direction is your endothermic. So increase in temperature is going to favor the increase in temperature is going to favor the endothermic side, which is a backward. Hence, the color of the mixture will turn brown. Okay. Now, let's see what else do we have. In this question number 17, we have this is ethene reacting with water and it's giving you ethanol. Okay. And they all are gases here. And the forward reaction is basically exo. Now, this reaction is an exothermic that has already been indicated by delta H negative value. The reaction is normally carried out at a pressure of 70 atmosphere and the temperature of this. So the equilibrium state, equilibrium pressure is 70 and the 300 degrees Celsius is the temperature. The reaction is carried out at 70 atmospheric pressure and 600. अब यहाँ पे इन्होंने क्या किया? Temperature को increase कर दिया rather than 300. Predict and explain the effect of raising the temperature on. Very importantly, they're asking about the rate of reaction. They are not asking about the position of the equilibrium. Their question is around the rate. So this is again यहाँ पर थोड़ा सा dodgy कर देते हैं question को कि position of equilibrium, ये हमने reversibility in terms of position of equilibrium पढ़ा है, ठीक है, कि फॉरवर्ड जा रहे हैं बैकवर्ड जा रहे हैं, इक्विलिब्रियम किधर शिफ्ट होता है. लेकिन कई बार दे ऑफन they're playing with the words, ठीक है. Instead of asking about the position of the equilibrium, instead of asking about the reversibility of the reaction, they're asking you about the rate of reaction. So whenever you're increasing the temperature, whenever temperature is a factor which increase the speed of reaction. Speed of reaction. Why? Because when you increase the temperature, what happens? The kinetic energy of the particles increases. Now, when the kinetic energy of the particle increases, there is going to be more frequent and there's more frequent and effective collision between the particles, and hence the reaction, hence the rate of reaction will increase. So what are we going to predict? Predict and explain. They're increasing the temperature. So we'll predict that the reaction speed will increase. The reaction speed will increase. So that is my prediction. Now they're asking you, why is it so? Because the kinetic energy of particles will increase, and that is going to it'll lead to frequent and effective collisions, and these frequent effective collisions is going to speed up the reaction. So they are not asking about the reversibility, whether it will go forward or backward. So you have to read the question very, very carefully. Now, in the second part, now they're asking about the position of the equilibrium. So at the 600 degrees Celsius, when the temperature is increasing, so what will happen now to the position of the equilibrium? This reaction is exothermic. The forward is exothermic. So increase in temperature always favor the endothermic side. So according to our concept, the equilibrium will be shifted. The position of the equilibrium, okay, you'll write down the position of equilibria will shift in backward direction. Will shift in backward direction. Now, what will be the reason for that? You have to give the explanation for the answer, because the increase in temperature favors the endothermic side, endothermic reaction, which is backward reaction. Okay, so this is how we'll be answering this type. So we have to be very clear and read it very carefully, whether they're asking about the rate of the equation, rate of the reaction, or they're asking about the change in the position of the. In this question, they have given us a data in the form of a table, and we have to interpret the data, we have to analyze the data, and then we have to give our predictions. Okay. Now, first part of the question, let me read the question. It's from October, November 13, and the question says that hydrogen iodide is heated in a closed system so that none of the gases escapes out, and the following dynamic equilibrium is established. So this is my equation, and along with the equation, they have mentioned that this reaction, the forward reaction is basically my endothermic. How do I know it's endothermic? Because the value for enthalpy change is positive, so the forward is endo and the backward is going to be my exo, automatically the reverse of the forward reaction. What is dynamic equilibrium? It's a 2 mark, so we'll write down where the forward reaction and the speed of forward and the speed of backward reaction is same. So there is no net gain in any direction, right? So this is what we'll be mentioning. So the first mark is for writing the speed of forward and the backward reaction is same. And the second is that there's no net gain in any of the directions. That means the equilibrium, dynamic equilibrium will be maintained, right? ना तो आपका forward direction में आपको product ज़्यादा मिलेगा, ना backward में, तो dynamic equilibrium maintain जब होगा, ठीक है? Coming to the question number part B. Okay, it says that there is a table which shows the concentration of hydrogen iodide, hydrogen and iodine. So you have the concentration of hydrogen iodide, hydrogen and iodine, all of them are gases. Okay, so they have given you the concentration of all these three over here. Now, after this, the concentration is mentioned at 25 degrees Celsius and the concentration is shown at 450 degrees Celsius. तो 25 डिग्री सेल्सियस पर जो कॉन्सेंट्रेशन है इनकी और 450 डिग्री सेल्सियस पे जो कॉन्सेंट्रेशन है वो इनकी, और ये हमें पहले ही पता है ऊपर से कि रिएक्शन जो है ये फॉरवर्ड रिएक्शन जो है ये क्या है, ये एंडोथर्मिक रिएक्शन है, ठीक है। अब यहाँ पर ये जो है रिएक्शन, अब हाइड्रोजन आयोडाइड की कॉन्सेंट्रेशन जो थी वो 0.94 at, let me write down the equation here once again. So it's 2Hi is giving you, it's giving you hydrogen plus it's giving you I2. So initially we'll start, this is the reactant. So 0.94 at the 25 degrees Celsius is giving me the same concentration of hydrogen and same concentration of iodine at 25 degrees Celsius. At 450 degrees Celsius, what happens here? I have 0.79 mole per dm cube concentration of hydrogen iodide and 0.11 moles per dm cube of both the reactant, because both the product are one volume, they have the same volume, so you're getting the same concentration of both. Now the tube has a volume of 50 cm cube. Okay, the tube has a volume of 50 cm cube. Calculate the mass of hydrogen iodide in the equilibrium mixture at 25 degrees Celsius. In this question, we will calculate the moles of hydrogen iodide, okay, the moles of hydrogen iodide in 25 degrees Celsius. So what is concentration? 0.94 moles per dm cube. So in order to calculate the moles, which we'll be doing definitely later on, so moles whenever the concentration is given, so we have this formula, concentration into volume over 1000, right? So we will be having the concentration that's 0.94, and volume is how much? Is they have not specified, divided by 1000, okay, into 50. Yes, sorry, volume is 50. So when you multiply 0.94 divide by 1000 into 50, you will get the number of moles. That's the first formula. Now when we have the number of moles, we have to convert this into the mass. The second formula is moles equals to mass divided by mr, or because we need to find the mass, so we will rearrange this formula. We can say that mass is equal to moles into mr, relative molecular mass. So when we, whatever the moles we're getting here, we will multiply that by the mr, we'll multiply that by the mr of hydrogen iodide, and we will get the mass here, and the mass is going to be in grams. So this is how, these are the steps how we will be calculating. The second part, may they're asking, describe and explain the difference in the concentration of the reactant and product at 25 degrees Celsius and 450. Now we have to compare the concentration at 25 degrees Celsius and 50. So when there's an increase in, when there's an increase in temperature, we can very well see the increase in temperature is actually from 25 it's moving to 50 degrees Celsius. Double the temperature has increased, but the concentration का जो impact है वो क्या हो रहा है, concentration जो हो रही है वो आपकी basically uh, is it increasing or decreasing? The concentration of the product is increasing. The reactant, ये आपका reactant है, ये आपके product है, ठीक है? तो we can see that the concentration of the product जो है वो increase हो रही है, और reactant जो है वो decrease हो रही है. तो this is again stating that the product जब increase होगा तो ये आपको automatically it's proving that the forward reaction is endo, because temperature increase होने से आपके जो product हैं उनकी concentration जो है वो increase हो रही है. ये फर्दर प्रूव कर रहा है कि आपका रिएक्शन जो है वो आपका एंडो है. डिस्क्राइब एंड एक्सप्लेन द डिफरेंस इन द कॉन्सेंट्रेशन ऑफ द रिएक्टेंट एंड प्रोडक्ट एट 450. तो 450 दे हैव ऑलरेडी स्टेटेड अप देयर दैट दिस रिएक्शन इज एन एंडो. तो प्रेडिक्शन क्या होगा कि व्हेन वी इंक्रीज द डिफरेंस इन द कॉन्सेंट्रेशन ऑफ द रिएक्टेंट एंड प्रोडक्ट at 25 and 450, 25 पे you will be having more concentration of reactant and product, or at 450 किस तरह से change होगा, क्या difference होगा at 25 degrees Celsius and 450. जब आपने temperature increase किया तो definitely reaction will be going in the forward direction. So at 450 you will be getting more of products, ठीक है, as compared to 25. At 25 degrees Celsius, you'll be having more of reactant. At a lesser temperature, at the lesser temperature, more of reactant. At a higher temperature, you'll be getting more of product. Why? Because the forward reaction is endothermic. When you increase the temperature, you will be getting more yield of products here. Whenever such question comes, you can take the data you with on the basis by referring the data, referring the value from the table. You can support your answers by the value, and then you will be explaining your answer. Okay? You will take the values in order to support your answer and use those value to explain your answer. Okay, that's all. So with this, we end with the